Okay, let's look at another one. Can we be sure that this initial value problem only has one unique solution? Well, do the check. I have the dy dx isolated for us already. So here is the function f of x, y. Let me write this down. This is e to the x times cosine of y. And now, here's the point, right? This is 0, and we have the y value is pi over 2. And let's see. If I plug in 0 into x, e to the 0 is good. It works. And if I plug in pi over 2 into y, cosine of pi over 2 is 0. But it's a nice number. And all in all, it works, right? And you see, e to the x is continuous. Cosine of y is also continuous. Altogether, it is, of course, a continuous function. So now let's just indicate that it is continuous around the point 0, pi over 2. So that's the first check. And now let's do the partial of this with respect to y. So I'll put this down, partial of this with respect to y. All right, e to the x will be considered the constant in the y world. So let's bring it down, e to the x. And now we have to differentiate cosine of y. The derivative cosine is negative sine, right? And then we have the y right here. And let's do it real quick. Plugging 0 into x, it works. E to the 0 is continuous, it works. And things like that. Pi over 2 into y here, sine of pi over 2 also works. It's 1, right? Negative e to the x continuous, sine of y is also continuous. Altogether, once again, it's continuous. Nothing will go wrong, right? Nothing will go wrong at all, technically. So this right here is continuous for sure. Continuous. And let's just indicate that it is around the point 0, pi over 2. But in fact, both of these are continuous everywhere. All the x values, all the y value, okay? And since these two things are both continuous, can we be sure that this right here has to have one unique solution? Yes, right? So right here, I will put down yes. And once again, it's the existence and uniqueness theorem for this. All right, so we cannot have two answers, not possible, okay? We cannot have three answers, not possible. And we cannot have no solution either. We must have one answer. Keep in mind, we cannot have no solution either. We must have one answer to this. And now, let's solve this. So, let's once again separate the variable. Let's multiply dx on both sides. In the meantime, I will divide the cosine y on both sides, okay? So in this case, let me just show you guys all the work. I will have, well, I don't know, let me just divide this cosine y. So that will be 1 over cosine y right here. And I will multiply dx on both sides so that this and that will cancel, this and that will cancel. And the reason I want to show you guys the work right here is that when I divide cosine y on both sides, this is 1 over cosine y. So I can write that down as secant of y, isn't it? And then we have the dy right here. And this is equal to e to the x. And we have the dx right here. All right. And now we can integrate. We have to integrate both sides. So integral of secant y, this is ln absolute value secant y plus tangent y, right? And just put a plus e on the right hand side. This is equal to the integral of e to the x. It is just e to the x, and then you add a plus e right here. Okay? And now, can we solve for c? Let's take a look. Okay, this means x is equal to 0, y is equal to pi over 2. And if you would like, let's just set this up for you guys. This is ln, absolute value, secant y, which I said it is pi over 2. And then we add it with tangent. And the y here is pi over 2 as well. And the x is 0, so we have e to the 0 plus c. This is 1 plus c. What is secant of pi over 2? This right here is technically 1 over cosine pi over 2. But what's cosine pi over 2? It's 0. And this becomes 1 over 0. This is bad. This is real bad. Likewise, in fact, tangent of pi over 2, it's also not defined, right? So you see, I'm stuck because at the moment this is undefined. It's like, oh my god, I don't know what to do with that. It seems that I cannot solve for C because this right here is not defined. So what should we do? Does that mean we don't have an answer to this at all? Well, we must have one answer for sure, right? One and only. You are my only one, that kind of thing. You must have one answer for sure because of the existence and uniqueness theorem. It's guaranteed that we must have an answer to this. In terms of the function-wise, we're stuck because the usual procedure wouldn't work. How about let's check if there's any constant function that will make this work. Well, since we have y of 0 is equal to pi over 2, the constant function suggests us, let's say, y of x is always equal to pi over 2. Will that work? Let's see. So I will just write this down for you guys. In fact, that's the solution to this. In fact, y of x, pi over 2, okay? In fact, this is the only answer, okay? The only solution to this. All right, just to verify this real quick for you guys, okay? If this is the function, this is the constant function, right? And I will differentiate both sides, which is dy, dx, that's a constant, so you get 0. And what we will do is we plug in these kind of things back to the original. Plug in dy dx, which is 0 right here. I'll put on blue. Is this equal to e to the x? And we have cosine y, right? So we have cosine. But y, we said is the constant function pi over 2. Check this out. On the left-hand side, we have 0, and this is e to the x. And since this is the constant function pi over 2, right? Cosine of pi over 2. In fact, it's always 0. Yes, 0 is equal to 0, so it works. Look at that. So, in this case, we don't have a nice, like a function that actually is a function that changes. We don't have an answer for this right here. But we do have a constant function, or constant function for the solution. And this is the only answer that we have. I told you we must have one and exactly only one. If it fails over there, we just have to go back and make sure if it works or not. And this is the only one. And by the way, y of x is equal to pi over 2. This is true for all x, right? That is the idea of the constant function. So of course, when you plug in 0 for x right here, it satisfies this right here as well, right? It satisfies the initial value. This is it.